In this example, we're looking at the different types of measures of position. Right now, we are actually going to look at example 6 leading into example 7. So we're actually going to look at example 7 in more detail just because it does extend on the previous example. And it's going to use the quartiles that we previously saw. So notice in example 6, the posted speed in a construction zone is 25 miles per hour. The recorded speed of 14 randomly selected vehicles is recorded. And here we record the miles per hour in the construction zone. Now, anytime you're given data like this, we would like to interpret data. And when it comes to quartiles, we'll also be looking at the one-bar stat to give us the quartile Q1, Q2, and Q3. And the reason that's important is because it leads into the last measure of position called the outlier. So outlier, it's unusual behavior in a data set, and we can actually mathematically calculate outliers. The way we calculate outliers involves two formulas. The lower fence and the upper fence, it's a region, if you will, that contains the acceptable miles per hour for a data set. Anything that lies outside of the fences is considered an outlier. And the way we calculate outliers is by finding Q1, finding Q3, and we need the interquartile range. That's a formula previously here. IQR is equal to Q3 minus Q1. So what I want to do in example 7 is I want to take a 15th data value, 100 miles per hour, and place it into the data set. So when we think about it, there's a construction zone, right? In the construction zone, we're only allowed to go so many miles per hour. And when you think about 100 miles per hour, if we're only allowed 25 miles per hour, would 100 miles per hour be considered unusual? It would be. Intuitively, it would be considered unusual behavior for a vehicle. Well, an outlier is unusual behavior in a data set, and what I want to do in example 7 is show that 100 miles per hour is an outlier. So what we'll do is we'll take the data set and plug it into the calculator. Here I have the TI-83. So here, let's get this going. There we go. Go to stat edit, okay? And I've placed the original data set already. These are 14 vehicles that I've recorded in the calculator. So what I'm gonna do is I'm gonna go to the 15th entry and I'm gonna enter 100 miles per hour. Okay, I want to prove that 100 miles per hour in a construction zone is mathematically an outlier. So let's quit to the home screen. Okay, so when it comes to the formula, lower fence is equal to, let's try that again. Okay, that's Q1 minus 1.5 IQR. Okay, and the way to find the lower fence is to calculate this formula here. Okay, so to calculate the formula, let's find the quartiles in the calculator. So going to the calculator, the setup is to run a one-var stat. So stat, calc, one-var stat. And here we're looking to run a one-var stat on our data set. We placed our data in L1 and then hit enter. A lot of information we've learned so far, right? We've learned about the mean, standard deviation, and if you go down, we also know where median is as well. These numbers right here, the min, Q1, the median, Q3, and the max, that's known as the 5-number summary. And in the 5-number summary, it tells you your quartiles. It says that Q1 is 28, so let's make a note. Okay. Let's make a note of Q3. Okay. Q3 was 39. Okay, and let's make a note of the IQR. Q3 minus Q1, that's equal to 39 minus 28, that's equal to 11. Okay, so now that allows us to calculate the lower fence. So lower fence is equal to Q1, which is 28, minus 1.5 times 11. Here we can use a calculator to help us calculate the lower fence. So we have 28 minus 1.5 times 11. And the lower fence is going to be the smallest acceptable miles per hour that the data can observe. Okay. Likewise, we'll calculate the upper fence. So the upper fence, that's equal to Q3 plus 1.5 IQR. Okay, so that's going to be Q3, which is 39, plus 1.5 IQR, which is 11. Okay, so let's proceed. Calculator. Okay. So the largest acceptable behavior for the data is 55.5 miles per hour. Okay. Okay. So what does that look like? So imagine we have a horizontal axis. Okay. And on that horizontal axis, I'd like to draw the acceptable region, the acceptable boundary for the data set. So I'm going to draw the lower fence with a big square bracket. And on this axis, I'm going to call that 11.5. Likewise, we'll take the upper fence with a square bracket. The value on the horizontal axis here, we'll call that 55.5. And this is the acceptable region here. Okay, everything as far as the original data set goes, as long as it's in here, is okay. So if we go back to the original data set, notice we have 20 miles per hour, 24, 30, 33, 38. All of those lie between the lower and upper fence. So those are considered acceptable behavior for the data. But our goal was to show that 100 miles per hour, I mean, just thinking about it, 100 miles per hour, it's unusual. As long as that value lies outside of the fences, it could be on the left side or the right side. As long as it lies outside, it's considered an outlier. So for that, 100 miles per hour would be somewhere here. Since the value lies outside of the fences, then 100 miles per hour is considered an outlier. So the nice thing when it comes to the quartiles is it allows us to calculate outliers. It allows us to find what data values are unacceptable or unusual behavior when compared to the behavior of the rest of the data set.